All right, welcome to part 5 of the iCom 7000 converting to digital. It's like the fourth take on the audio dubbing, so if this voiceover doesn't work, I'm sorry, but this is what you're going to get this week's video. Jeez, now I got to sneeze. Okay, whatever. So anyhow, before we go and jump into into making this doing the IF tap, let's talk about the cab that I've been using. I've been getting a lot of requests about this. This is the GeeekPi desk. It's a 12-inch mini rack. You can get them in 3 different sizes. Here you can see I picked the middle size, but yeah, you pick the one that's right for your installation. Goes together pretty quickly and easily. I think the only mistake I made here was not properly aligning the rails so that plexiglass would feed in. So I had to flip it around and yeah, quick change, and didn't make that mistake the second time. Um, the nice thing about this thing is it's like an erector set, right? I can put it together, take it apart, reconfigure, move the shelves around, do whatever I want, and you'll notice that from the first video in the video series to where this is today, and even beyond, it's already changed since the editing of this video. That I am constantly changing the configuration till I get everything the way I want. Certainly, I'm going to make some changes to the SDR unit itself, probably the displays. You'll see me here putting on the big display first, and that one is not part of what you've seen in the past, probably. And then the smaller display underneath it. These are both touch displays. From there, I can put the shelf in and the radio and everything else. But yeah, this is the GeeekPi. I'm going to put the parts for everything you're going to see here into the video, but in the description so you can look at it. I'm putting together some of the internals. This is the Raspberry Pi. There you see a 12-volt power distribution to get me a 12-volt rail to everything I need. I'm also making a 5-volt one for all the monitors, the computer, and everything else. So that, yeah, what I'm installing right there is the 5-volt 10 amp power supply. That green box there is going to give me all the power distribution to various 5-volt devices. I've got some USB-C and USB. Okay, let's bring it up to speed. So this is my power station, getting kind of mocked up and ready to go into the back of the rack. Raspberry Pi, 12-volt distribution. Right now the rig's plugged in there, but it won't be permanently. It'll have its own direct source to DC for the current it's going to draw. I am providing 12 volts. 5 volts, that's 5 volts for the computer. Through my 12-volt. I'm providing 5 volts through this distribution panel that you see me set up momentarily ago. And that's getting 5 volts from this 10 amp regulator. That regulator gives me 12 volts in, 5 volts out, 10 amps, which is going to be plenty for the Raspberry Pi. But let me tell you, this little sucker is power hungry. He wants 5 amps and has got to have it. And the Raspberry Pi power supplies are really borderline, even the ones that are supposed to be for the Raspberry Pi 5, they're really barely able to keep up. I'm going to pause it right here. I will, in the description, provide you 2 lines of code you'll need for the Raspberry Pi. Because what I've provided here is not an official Raspberry Pi Foundation power supply, it assumes it is not capable of providing 5 amps. And when you power the Raspberry Pi up, it'll give you warning errors saying that the peripherals have been, output to the peripherals have been reduced because it's not 5 amps. So we're going to give you a little command line. We're going to hard code that and set it to 5 amps. The power supply is capable of 10 amps, and that's plenty to power this Pi and my displays and the other peripherals. So don't worry about that. We've got a couple lines of code that'll get you around that. Especially when you start adding peripherals like this cooler, and all the stuff, we're going to hang on to this. So the solution to that is a USB-C and USB. It's got a little mixture in there. Hub. The hub is powered with 12 volts. It comes with 12-volt wall wart. I set that aside and will use that for other projects. And I have created my own 12 volt to the what do I call Powerpole. So it's powered separately. Otherwise, if I plugged all this stuff into that Pi, first of all, I don't have enough slots. Secondly, it would just, the power supply would just quit. So what do we have here? And this is just still in mock-up stage, but I've got the power to one of my displays. That's a touch display. I've got power to the other touch display, which this will come out of here and eventually go straight straight to one of these outputs from the power distribution. And I'm going to do that because I don't want the second touch screen to be a touch screen. They interfere with each other, running two touch screens at the same time, and and if you bump it, it's just kind of confusing. It's just going to be a display for me. That's the one with the that it's used in the rig. I'm just marrying the rigs, so it doesn't need to be a touch. It's not. There's no touching. All it does is mess with the other touch screen. So that one will come out eventually. I just got to get the right jumper cable. What else do I got? I've got it. This is my new This is one of the SDRs. Not sure this is the one I'm going to settle on, but probably something like that. Right now it's on an antenna because I don't have the IF tap in yet. But once the IF tap goes into the radio, then this antenna comes off and this feeds into the IF tap in the back of the radio. Here I have a GPS module. This is for the keyboard. Hey, stay focused. The little one here is for the keyboard. Then I've got, oh, I already talked about that one. It's the other display. Here is powering the, this powers my converter. Oh, no. This is, no. This is CIV. So this one is my CIV line. So that's for cat control, right? That's going to go to the back of the rig for, that's how we're going to manage cat control. Which, goes to the back of the radio. This is a cheap audio, right? From my input-output audio for digital modes. Sound card. We talked about that earlier in a previous, if you're using a Raspberry 4, this is built in, you don't need it. If you're using a Raspberry 5, you'll need some kind of an interface. Toads makes a really good one, the guys, Theo and company. I also have a few others I'll try. This one here is simple, very inexpensive, but then it leaves all the balancing to you manually. You will manually have to set the gain of the radio to a certain volume and manually have to, and if you don't get it right, you're going to get bit errors. So it's a lot better to get one of the more sophisticated ones where you can set those levels once and forget it. But this is in here for the mock-up. And then finally, one last power that's powering that powers this device here, right, that we talked about. And this is my HDMI. This is the composite video to HMI. Yeah, this is how I get the video from the back of the radio, the old school composite video, to modern HDMI display. Went over this in the previous video, but I'll put the part number and name on in the description anyhow, just to see if you haven't seen it. Of course, that goes to one of the HDMI monitors back here. So up here I have the first, this is the touchscreen HDMI, the wide one. Below this is the back of the little HDMI screen, which is just the mirroring of the radio. Then there's the radio itself. Now I will cut all these wires once I start to build this out. This is still the mock-up stage. I will cut and dress all these wires to the right length so that it's just enough for the run I need, and nothing hanging out the back. The other thing that's very precarious is none of these things on the Raspberry Pi are strain relieved. You can see that already flexing. I'm going to have to get in there and create some jumpers in here to strain relief, strap these and strain relief it. Otherwise, it is not going to be robust for transporting around. Okay, So this is the power station. I'll put the part list on, but here's my Raspberry Pi 5. This is a little Chinzu. I'm amazed with this power distribution. West Mountain Radio, look out. This thing is aluminum. It's the fit and finish is excellent. That's powder coated. The printing, the on here again, outstanding. I don't think these are real power poles, but it looks like the same kind of DX Engineering cells. So yeah, again, I'll put the part number onto that. This is a little 5-volt power supply. It's going to create my 5-volt rails for all the things in here that are powered by 5 volts, which is a lot. Yeah, maybe I'll put a port out to charge my cell phone as well one day. But and then finally, yeah, a USB hub. I got one this size, and I am already almost out of space. So you might want to get one a little bit larger. It depends on how many displays you plan on driving. Yeah, I'm going to the new elect, or the SDR is going to be fed directly from the Pi with one of its high-speed ports, as well as the sound card. And of course, one of those monitors are going to come out and be wired to disable the touch screen. So all that together, I'm going to free up 3 more USB 3.0 ports. And I still got 2 3.2 ports available. So all in all, I will have enough. But yeah, you calculate carefully, make sure you're getting the right size one if this is the way you're going to go. Otherwise, you run out of these ports really fast. If you're going to use a UPS, if you're going to use a GPS, the keyboard, again, wireless keyboard, you'll need at least one for that. So I'm full. Now, one of these comes out, so I got 1 extra spot left, and I still got 2 USB-C spots left, which I can plug into. So I think this will be enough, but it's going to be close. All right, let's just bring you up to speed. Here's the 7000. It's mirrored display that is still under touch control because I don't have an adapter cable yet. So if I touch this, this reacts, and we don't want that. We just want to touch this. So here's the pan adapter SDR. Not IF tapped yet. We'll get that in a future video. We come around to the back. Now I have not done any trimming of wires or anything. Where's my light? I left it in there. Okay, so there's your Raspberry Pi and all the power management stuff that we just worked on. Here's my USB-C, what do we want to call this? The port adapter, the extender, with all its stuff hanging on there. Here's the back of the rig, and that's for the batteries when I get that built up. So obviously when I get closer with all this and we get to the final configuration, all those wires will be cut to length, so there's nothing really excess in there. But again, this is still in the prototype stage, but hopefully you can follow along and decide how you want yours to look. All right, here I am putting together a back panel faceplate. I want to get basically I want to port out everything I can from the back of the radio, so I'm not reaching inside when I want to connect or disconnect antennas. So there you're seeing a SO239 for the HF side, and I went ahead and put an N connector for the VHF side, and that way I can quickly tell you which VHF and which is HF. I wish they would do that with the radio and just put proper N connectors on anything that's VHF, UHF, but they didn't, but I just did. So that's fixed up. you can see here I'm just using basic tools, no fancy laser cutting or anything like that. You don't need all that. A simple drill. Here I'm going to put in Powerpole distribution. So this is feeding the power in. It'll also allow me to feed in from my batteries. And then the back side of this is going to come out into that Chinook power distribution panel that you saw, as well as maybe powering the radio directly and a few other things. So again, simple tools. Took a Dremel tool here, and let's just cut this thing carefully. I don't need anything special other than just what I consider my household tools. You may or may not have one. If not, find a friend. Somebody's got one. And then just take a little time with the file and get those corners all nice and clean and crisp. Yeah, you can see my great videoing here. I still haven't mastered keeping it in the screen, but hopefully you're seeing everything that I'm seeing. I also put a Cat6 cable in the back so that I can directly feed Ethernet or internet to the Raspberry Pi whenever I am in the shack. I don't have to be reaching around there to do that. And there we go. So that has pretty much brought us up to speed where we're at this week. I will have everything in the I'll put everything in the description that I can as far as parts. I really need to hear from you guys. There's about 300 or 400 of you following this series. What are you using for a computer? x86, i.e. Windows? Are you going to use Raspberry Pi, i.e. Linux box? Are you planning on using the 12-inch rack or whatnot? Again, if you've got pictures, send me what you've got. I love to share them with the group here because, we all learn from each other, and then finally, if it's not in the description, we'll pick it up next week. I guess I will add a couple more videos to the end of the series to make sure we're covering the installation and kind of the setup of these digital modes. Although there's lots of good videos out there, so but if you're already, let me tell you this, if you're already at this point, please get it installed and working yourself. Next week, we're going to put the IF tap in, and you're going to want something to connect to that tap and start testing. So this is kind of an important kind of a break point here, first of the year. Get caught up with where we're at. Make your decisions on what SDR you're using, what computer. If you've got the ability, go ahead and get that software loaded. Get the CIV controls. That's just the regular programming cable onto your rig. And so that next week when we get the IF tap going, we can go straight to configuring that. Anyhow, 7.3s, guys. Happy New Year. Wish you the best, and leave a comment, please. Let me know how you're doing. Talk to you later.